object is moving in a circular path, there's no doubt. Now the reference point, I can change it. Let me start with O point P1, P2. This is the center of circle. The object is here. It is moving with a constant speed in a circular path of radius r. This also at a distance r and r. So when the same object comes here, I'll ask you what will be the angular velocity of the particle about C, about P1, about P2. I can define about any point. Actually what happened, the particle is moving. Particle is moving in circular path. With constant speed v. There's a condition. Now I'll ask you, find angular velocity of particle about point C, comma P1, P2 when it is at B. About C, what should be the angular velocity? Here only angular velocity about C. Omega C should be equal to V by R. Omega P1. So what is the how is this velocity? Perpendicular to position vector. So therefore this will be V by R plus R. Then about this point, to R plus R, or if you want to write some X, it will become very important for you. So if a particle moves in a circular path with a constant speed v about its center, then what will be the angular velocity about any point on the circumference? Will be V by 2R. If V by R is omega C, about any point will become half of that one. Means what is the meaning of this? Not only like this, we can conclude here now. About C, angular velocity is omega. Somewhere some arbitrary point I'll bring it. About P, how much it will be? So for that, what you can do is, this is a velocity. This is a radius R. Then omega C, how much you write? V by R. What about P? About P means what we should do? Again, we have to bring a mathematics like this. This is a radius R. Okay, fine. Okay, this will be. So what is the point P now? Point P is some arbitrary point on any circumference, anywhere. About P, how much it will be? What we should do? So we should go for this calculation R. We should resolve. You should resolve component of velocity perpendicular to it. Solve it. You'll again end up with V by 2R only. If omega C is the angular velocity of the particle about its center, then about any point on the circumference will be half of it. I'll ask you now to calculate about this. I think you know mathematics. Carry on with the mathematics here. Okay, this will be theta, you take it. If this is theta, this should be theta, this should be theta. There's a totally different problem. I just brought a generalized thing. What is the angular velocity? About center is omega C equal to V by R. No. So we'll go for omega P. Omega P, what omega P should be equal to? Omega P should be equal to V cos theta by R. Anybody how to bring R? the triangle. Now what can be this? R cos theta, R cos theta. So what is R? You can write V cos theta by 2R cos theta. So V by 2R. What is V by R? What is the conclusion you can make it? If omega c is the angular velocity of particle about its center, then about any point on the circumference, what is the angular velocity? Will be half of it. It was very simple. I found here mathematically I am bringing it. What is point P? Point P on the circumference. What is omega c? Angular velocity about its center. Then what is angular velocity about any point on the circumference? Will be half of it. So there is one golden statement. The angular velocity of a particle about any point. About any point is telling where the point, let it be wherever it may be. About any point on the circumference is equal to half of the angular velocity of particle about its center of circle. This is last conclusion is a general one, very generalized one. Sir, can you calculate the centripetal acceleration? As few quantities we can calculate, few quantities not possible. We have to total acceleration not possible. Centripetal acceleration, how you define? An equal to v square by r. V cos theta we know. We know this radius of curvature. We'll get the centripetal acceleration. It will have tangential acceleration. It will have radial acceleration. Total acceleration very difficult to calculate. Again, you should differentiate dr by dt. It's a big headache all. Just have some general idea. So it's not like something object moves in circular path. Okay, we are going to discuss circular motion. No, let it move in a straight